Okay. Excuse me. I'm so sorry about that. Okay, so what we're going to do is we actually are starting with two thin pieces of metal that are actually welded together to make some kind of frame. And so if this is in the Y direction, this is in the X direction. Okay. And they are welded together to make a right angle. And we actually want to find what is called the frame's center of mass. Okay, so what we need to do is, what we're going to do actually is look at, and we're going to assume, we're going to actually assume a constant density. So the material actually has a constant density. And so what we're going to do here is actually look at both of the rods separately first and foremost. Okay. And so typically what you would assume, okay, so it's kind of logical for us to assume that for the rod in the X direction, the center of mass is right exactly in the middle, right? So that would be our logical assumption, especially since it's a constant density. Okay. And then you would also assume that the rod in the Y direction is also in the exact middle of the thin rod. Okay, so those are pretty good, um, safe assumptions for us to do, especially since um, it's a constant density. Now, if the density fluctuated from one end of the rod to the other, that wouldn't necessarily be the same, right? So since it's a constant density, then it's safe to assume those. But now we need to think about them, think of welded together. Okay. And so what we need to do is we need to actually kind of think of the center of mass for the entire frame in the X direction. Okay. And so if I look at this as 0, so this is at 0, and this is length L, and that's 0, and this is length L. Okay, so we remember that the center of mass is actually equal to the sum of the masses times their distance away from kind of that origin or pivot point divided by the total mass or the sum of the masses. Okay, that's another way to say that. That might be a little bit better to say. So if we look at this, then I know that here, all of this mass in the Y direction is 0 away from the length, right? So this would be the pivot point, and it's all right here, and so he is a distance of 0, and plus the mass of, in the X direction, the mass of this is L over 2, because that's where it's kind of concentrated. And then this is going to be divided by M plus M. So this is going to be L over 4. Okay. And so now we can do the same thing for the Y. So it's the same process. And so now we have M times 0 plus, nope, we're going to flip that around. So at in the Y direction, we have L over 2 plus M times 0, of course, over M plus M. So this is going to be L over 4. And so this is the frame's center of mass.